the speakers on the desk to take their seat. It's a pleasure to welcome you all here in the University of Milano-Bicocca in our Aula Magna for this opening workshop dedicated to the designing of the next generation of sustainable textiles. This is a workshop supported by the European Commission, by the project Integrano and by ACTC. Is an opening workshop for the next conference starting at the end of this workshop after the coffee break, and the conference will be dedicated to the world of the plastics impact on the environment in a broad sense. And we will have different speakers today, and so we will go quite fast in this workshop, but I would like to leave the floor to our prorector, Professor Luca Beverina, for the welcome addresses. Thank you.
Thank you very much, and welcome to all the people in the room and all the people connected. It's a pleasure to introduce this workshop on sustainable textiles, particularly because I'm a chemist as well. So I am still involved into textile chemistry. And just a couple of random thoughts, and then I'll leave you to your workshop. Textiles are a fundamental class of materials and enabling technology. It's difficult to imagine our everyday life without a form of textile, okay? And the development of natural and artificial textiles has fostered many of the advancement of our civilization. Yet, textiles are becoming a bit of an issue, mostly because they outperform our design criteria. They are much more stable than we would like them to be. And at the end of the use, they're still around, and we have to cope with them. Now, because of that, the concept of sustainable textiles from raw material point of view, life cycle point of view, different kind of textiles that can be manufactured for the sole purpose of their use, not becoming an issue after the use, are an important topic as well. A topic that is no longer confined to the polymer chemistry I was trained in. Actually, the textile field is absolutely multidisciplinary. As multidisciplinary is the University of Milano-Bicocca, which was born 28 years ago around 3 departments: material science, environmental science, and biotechnology, which are all represented in the program of this work and also in the wider program of the Plastics and Environment Conference, which we will follow. This is an important sign because complex problem requires a complex approach, and the complex approach has to be a multidisciplinary approach involving all the people working on the technology, the policy makers, and I was particularly pleased to see policy makers actually in the agenda, and the general public. I am prorector of the 3rd mission, so the general public is essentially my kind of public. And I think that initiatives like these are a paradigm of what the 3rd mission should be. Because around the theme, which is as important for researchers, industry, and policymaker, the public can be gathered as well. Because everyone knows textile, or they think they know textile, and everyone is aware of the resources of textiles and also the problems of them. So very welcome to the University of Milano-Bicocca, very welcome to this workshop, and very welcome to the conference in the next 2 days, and thank you very much.
Now we have the only contribution by remote by Tilla Cross from ETP, so please.
Yes, hello, good morning everyone. Sorry I cannot be there with you in person, but I'm happy that you made it possible for me to share a bit about the Ecosystems community, one of the initiatives we at Textile ETP are facilitating, and that the Integrano project, that is also part of your conference, is a member of. I hope you can hear me well and still see my slides. So I will move on, and usually like to start with this slide, because what is Ecosystex? As I mentioned, it's a community of EU-funded research projects that all focus on textile sustainability and circularity. And you can see all our members here on one slide. And of course, the Integrano project in the top right corner is also part of it. A few words before we dive deeper into what Ecosystex is and what we do, the different activities that we do with all these projects, and why we exist. Who is the organization behind it? So the organization I work for, Textile ETP, maybe you know it already. In case you don't, we are the largest European network of textile research and innovation professionals, and based in Brussels. And our objective is, well, to ensure the long-term competitiveness of the EU textile and clothing industry through collaborative, market-oriented research and innovation. So we always try to bridge the gap that sometimes still exists between, well, the research and the industry out there, and support all of that on a European level. We bring many different countries together, many different companies from all these different countries, and the experts working there. What is it that we do? Well, as a networking organization, of course, networking is a core part of our activities, organizing conferences, webinars, and other networking opportunities. We also have different learning formats, 3 different innovation hubs, one for circular and bio-based textiles, one for smart and high-performance textiles, and one focused on digitalization. And we occasionally also act as a think tank, and of course facilitate in this Ecosystex community that I'll talk about on my next slides. And last but not least, one of our core missions is also to support our members to access EU funding. So we have annual brokerage systems where then, well, our members can meet each other and then form consortia and then apply or respond to these EU funding calls. Now let's look deeper into what the Ecosystex community is and why we created it. Well, we launched this initiative now, 3.5 years almost ago. And the idea behind it is really to create a permanent expert community and a central knowledge hub for practical application of EU-funded science, technology, and skills development for textile sustainability and innovation. And yeah, you can imagine a bit, right? We have all these different, by now 96 projects that we bring together, which is like a very big number. Out of those, well, I think around 60 are still ongoing research projects. So that gives you an idea of how many interesting projects are out there that do something linked to, well, textile research and innovation. And to bring them all together in one place and to make them easily findable, to make them connect with each other. That's what Ecosystex is for. So it's also one of our activities here on the slide, well, the inter-project collaboration, because of course in these projects you have many different partners that collaborate amongst each other already. But of course, between the different research projects, right, there are topics in common. So it's also nice for different projects to exchange with each other. So that's what we do with different working groups. Then we also occasionally engage with EU policymakers, because as you can imagine, you can see here we have over 510 experts in our community, and it's growing every month. There's a lot of scientific expertise that comes together. So occasionally we then also consult our experts for their input and then provide it to EU policymakers. And our third activity area is dissemination, in which we're also really active because, well, there's a lot of good, important, interesting work going on in all these research projects. So we also help them by making it basically a bit more accessible to the outside interested public to find these results. And we do that, for example, through different webinars and then also an annual conference. But more about that in the next slides as well. Here you can see the different working groups that I mentioned. We have these 8 different working groups, horizontal and technical ones. I won't go into detail, but here you can see a bit what they've been working on in the past. So, for example, in the first year, we published a research gaps and needs for the green transition of the European textile ecosystem paper. There was a joint publication with input from the member projects. In the technical working group on renewable materials and standards, they worked on an overview of standardization committees, published and under development standards, and a gap analysis for renewable materials and textiles. And current work in progress is that we have one working group focused on skills and education, and there they're currently building a TCLF skills observatory, where the aim is to bring all the relevant data on skills, labor, and employment in the sector together, and basically create another go-to platform to find data and information on these topics. And then we have a working group also on circular textile data, and there they're currently working on minimum data requirements for the recycling value chain. So as you can see, it's a very broad spectrum because, textiles is a very broad sector, and you can have so many different applications, as mentioned before. So this is just to give you a bit of an idea what kind of resources you can find in these different working groups. What else is it that we do? Well, as I mentioned before, it's mostly about also sharing the news and events of project when it comes to our dissemination activities. So we have a mailing list, LinkedIn, YouTube, a website that is frequently visited. So it's also a great addition for any project, basically, to have some additional visibility to the outside world. Something else that we are doing as well is we aim to bring all the public deliverables of all the member projects together in one place on our website, because I don't know how familiar you are with these research projects, but they run for a certain amount of years. There's a lot of work going into them. They have their deliverables at the end of the project, and then maybe the URL expires, and then all the results are gone, basically. Or if you don't know the project name, you don't find the results, but it's still really important and interesting work. So with kind of bringing that together in our database at Ecosystex, we try to make it also easily findable for anyone out there. And a third initiative we launched recently is that the experts within Ecosystex can review each other's policy briefs, because more and more projects are now asked to write policy briefs, give policy recommendations. And the idea behind it is also to make a policy brief a bit stronger if you show it also has support from other projects. So that's another initiative of ours. Coming towards the end of my presentation, here you can see some of our dissemination activities. As I mentioned at the beginning, we have a webinar series called Ecosystex Insight Series, in which we regularly invite our members to share their developments, their recent progress, or eventually their final results. The next one is next Friday on the 12th of June. So if you're interested, you're very welcome to register for that and see what it's like. Usually we also cover there a broad spectrum, so you can get 15-minute glimpses into many different research areas linked to, textile sustainability and circularity. And then we're also currently preparing for our annual Ecosystex conference, which will take place the 22nd to 24th of September in Antwerp. We're actually launching registrations today, so soon you will find out more information and the detailed agenda on our website as well. And the way these Ecosystex conferences work is that we partner with some of our member projects that then organize an interactive workshop. So it's not really a conference where you sit through presentations. Of course, there are some, But the idea is really to make it a good networking opportunity and an interactive event to collect input or share your results and validate them, things like that. So yeah, very welcome to join us there. And these activities are, like what is also written here on the slides, there to connect our members so they can exchange and share their best practices and potentially continue new research projects. So that's a bit what we do. If this was interesting for you and you're interested to follow more EU-funded textile research and innovation projects and to see what's going on, you're very welcome to follow us on LinkedIn and sign up to the public mailing list so you stay in the loop whenever there's something interesting happening in the project community. And of course, you can find a lot of information also on our website, like the database that I mentioned. And of course, you're welcome to join our future webinars. And with that, I'm I'm at the end of my presentation. So thank you very much. If you have any questions, very happy to take them if that's possible, the tech setup. And wishing you good conference in the next 2 days.
Thanks, Stilla. Thank you very much for a very nice presentation and very interesting for understanding how the joint activities and initiatives are very important at European level. The idea is to go on with the other speakers and then have the 5 or 10 last minutes for eventual question at the end of the workshop. So I would like to invite Stefano Cavestro from Associazione Italiana di Chimica Tessile e Coloristica for having his point of view on this issue, if you want. I don't see the presentation of Stefano. You have the
In ogni caso ci sarebbe stata la saggezza antica, sì. Perfetto. Okay. Good morning and welcome from my side. My presentation will take 10 minutes or a quarter, no more, please. The title is Sustainable Challenges in Textile. Everyone knows textile, everyone is talking about the impact on the environment of textile. Everything is true, nothing to be hid. But we will see today, okay, thank you, a small part of the textile process. Starting from a definition, what is textile enabling process? This is an official definition, but I would like to summarize it in enabling process is the sum of the entire steps in the production of a fabric. Those are the different steps, starting from the spinning, sizing, weaving or knitting, depending by the kind of fabrics, scouring and bleaching, dyeing, printing. Printing is divided into parts, traditional or digital printing, and at the end, the finishing. We will be concentrated or focused only on one step of this flow chart, on the dyeing process. I will stay on the surface of the entire process. We are not going into the details if it takes a long time for the discussion. Dyeing process from a chemical perspective. All dyes and chemicals, as you know, are regulated by European regulation, the REACH, as also by volunteer schemes, thanks to my friends Francesca and Elisa. Later they will show all the work they've done. Volunteer schemes zero discharge hazardous chemicals, Ecotex standard 100, for sustainability goals, and more and more, roughly 60, 70 voluntary schemes on the market, also by the brands. Everyone is taking care of a part of the chemicals, not for the entire process. From a technical perspective, what is dyeing process? First of all, what is the target for a dyer? Dyer is responsible for matching the right shade requested by the client. It means that the brand is coming to a dye house with a shade, with this red. Dyer has to match this red on different fabrics done by different fibers. It's really complicated. Is it easy? No, not at all. There are a lot of possible applications and variables in the process. I will show some of these variables. Fiber type, cellulosic, protein, polyamide, polyester, and acrylic, main fiber. Officially, we have 50 fiber, and some new fiber, synthetic fiber, are approaching on the market. Each fiber has some specific properties, and we have to select the right dyes for matching the shade, different class of application. Cellulosic, giving you an example, direct dyes, reactive, VAT, sulfur, and azoic dyes, azo dyes. Acrylic fiber is the easiest, cationic dyes. This what means that this is an average this is a summary of the liquid ratio requested by the process for each fiber. Liquid ratio means 1 kilo of fibers, how many liters of water is needed for the dyeing process. We are starting from 1 to 10, sorry, in direct dyes. It means 1 kilo of cotton, 10 liters of water, up to 1 to 20. Okay, you can see how many liters in the different fiber and dyes combination are requested by the industries. We have done a lot of effort trying to reduce the amount of water, but with the actual technology, we can't decrease. Water is essential for us. It's the solvent we are using for the dyes, and is also the fluid with transporting the fabric in the machinery. It's a double use. The temperature, the average. Each fiber, each dyes has the right combination of temperature. We have the same temperature for each fiber. We are starting from 95 degrees for the cotton, up to 120, 135 for the polyester. It's a huge amount of energy requested for the dyeing process. You have to think also that when we are dyeing polyester up to 135 degrees, we have to cool down the temperature, not only for the fiber, for preserving the fiber, but also for touching or for finishing the process. And the cooling process, for the cooling process is needed water, nothing more. So we have a huge consumption of energy for the heating up to 135 and a huge consumption of water for cooling down up to 80 degrees. But there's a nice point behind this. What happens if I made a mistake for matching my shade? I have to start from the beginning. It means that at the end of the process, this red shade is not the same as the client is requesting. I have to start from the beginning for matching again. Client is checking difference between this shade, the official shade, and the imitation I've done. If there are differences, they are requesting, please try to match better. And they have to start from the beginning. It means they have to start from the scratch. Usually we consider the starting point at 40 degrees. We have to start again, following the polyester example. From 40 degrees, heating up to 135, and cooling down again and again and again until we match the right shade. It takes time and energy and water, remember. Time. Okay, from an industrial perspective, time, you know better than me that is really important. Time means cost. Cost means the client is not accepting the final cost of the production. The driver in the textile industries is the price. Sorry, is the price. Often, brand is coming to the house and is commissioning a huge quantity of meters of fabric, but is imposing the price. So we have the dream or the target for the dyers is right first time. Matching has to be right at the first time, avoiding cooling, avoiding wasting of time. Okay, direct dyes or polyester. We follow polyester, starting from 60 to 120 minutes for each process, each dyeing process. Remember, if we are not matching the shade, we have to start again from the beginning. Okay. Typical water consumption. It's an average. It's not right, but it's an average. Direct dye starting from 40 to 70 liters by kilos. Polyester, dispersed dyes used for polyester, starting from 30 to 60 liters for kilos. There's a point. If we made the wrong imitation of the shade, we are not wasting the water, but we are using the same water. We are saving in a certain way water. But consider the entire volume. It means, sorry, it means 1,000 liters for each production of polyester, each dyeing process of polyester. We have 1,000 liters. We have to cool, to heat, to cool, and we have to add also chemical, dyes and chemicals. I made some notes so you can see what happens. Grazie. Ho l'assistente, grazie. Okay, notes are showing you what we have to do at the end of the dyeing process. The dyeing process is not finishing at the end when we are cool, but a lot of dyes are requesting an additional treatment. Dispersed dyes, following the same. Low water use in HT machine, minimal wash off is true, but at the end of the process we have to make a reduction clearing. It means that we have to release the bath, the dye bath, in the wastewater. We have to refill the machine, and we have to add caustic soda and sodium hydrosulfite for the reduction clearing process. And we have to heat up to 80 degrees for 20 minutes, and we have, at the end, we have to cool down to discharge the water in the wastewater, and we have to neutralize, again, refill machine with water, adding acetic acid, 10 minutes, again, water in the wastewater, the neutralization bath in the wastewater, and at the end we finish the entire process. Last question. I promise 10 minutes, no more. Do you remember what is the target for a dyer? The shade has to match the shade requested by client. I call this point the human factor. We match, I'm a dyer, I match the shade. For me, should it be perfect or should it be accepted by the client? But the client is a human. Today is happy, tomorrow not happy. Today is hungry. Who knows? Is human. I made a collection of some comments on the shade imitation. I translated it in English. Maybe I'm not the right translation. For the Italian people, start laughing, please. non è abbastanza anguria matura. This purple isn't right. I won't eat any more woman. What does it mean? Who knows? But the designer is requesting. It needs more color, but not too much. This look too bland. Sorry, you are laughing, but it's the truth. I made an interview from different colleagues on the market, and this is a small collection. It's a small collection. We are not talking about another point, the finishing. The finishing is regarding the handling of the fabrics. Okay, is another topic, more laughing than dying. I want it whiter than an egg white. Okay, you can copy it, there's no copyright, so you can go today at home and show it to your parents. Make this red strawberry stronger. And okay, there are a lot of comments. This is the main important point. From a chemical perspective, we are compliant. From a technical point of view, we are a good dyers. We are making it perfect, but at the end, the human factor has a terrible impact. What does it mean that is a textile sustainable? Yes, from a technical perspective, from a chemical perspective, but in the end, this is the more important point. The human factor, the feeling of the designer about the colors. That's all. Thank you. I need to leave, sorry, I need to go to the airport. If you have any question, please feel free to contact me by email or by phone. Thank you so much for your attention. Have a good day.
Thank you, Stefano. Very interesting and nice presentation. Now we have Elisa Gavazza from CITA DHC, Roadmap to Zero program. Thank you. Questo giusto?
Sì. Sì, no, solo la lettura. Sì, se no schiaccio. Oh, vado bene. Okay, thank you very much. Good morning, everyone, and thank you for the opportunity for being here today. My name is Elisa Gavazza, and I'm representing ZDHC. That means Zero Discharge of Hazardous Chemicals. ZDHC is a global multi-stakeholder organization driving sustainable chemical management across the fashion industry. So you have just seen a snapshot on production processes, how many chemicals they use, how much water they use, and ZDHC is really trying to tackle this issue of possible toxicity of chemicals used in the textile and leather industry and making it more sustainable. For many years, sustainability effort focused primarily on legal compliance. So basically, companies ask themselves, are we meeting legal compliant requirements before putting a product on the market? But today, this is no longer enough, and ZDHC has played a key role in this because the organization was able to shift the paradigm from conformance, as you see in this slide, to a proactive supply chain management approach and innovation leadership. The real challenge has been to focus on how sustainable chemical management can become strategic for the risk reduction, for the innovation, for the transparency, and also for business resilience. When we start talking about chemistry, sustainable chemical management, you are a very technical audience, but usually people are like scared. So they say, oh, no, I'm not a chemist, I cannot speak about it, or I don't understand anything. So do what you need to do, but I cannot support. But at the end of the day, sustainable chemical management is really a risk management approach. So you don't need to be a chemist to do it. Let's say that the aim of ZDHC and the reason why ZDHC has been founded is because no single company can solve the environmental challenge alone. So if we consider how wider and global are environmental challenges, we can easily understand that even if a company is a leader in sustainability, but all the rest is, not playing so well, we don't solve the issue. So at a certain point, the textile and fashion value chain decided to join effort and to create an NGO, which is ZDHC, to achieve these meaningful changes. And the three main elements that ZDHC is, has been founded for is because of the collaboration. So we see sitting at the same table companies which are competing on the market. So big brands, big retailers, as well as suppliers or the chemical industry, they are all sitting together and trying to solve the problem of the chemical pollution. The other key point is the transparency. So our program is publicly available. If you visit our website, you can see all the guidance document. This is because we would like to reach out the more wider audience possible. And the third point is the commitment. It may seem, strange when you speak about technical aspect to also look at them from a commitment perspective. But the commitment is very important because companies agree, decide, and sign their decision to implement the ZDHC Roadmap to Zero program, which is the program owned and developed by ZDHC. And this is very important because, first of all, when you start in the company, you have to, modify processes, you have to include new SOPs, then you have to commit to it. It's the first step for any sustainability program. So these three pillars are there since the beginning of ZDHC. And I think that the success of ZDHC comes from creating a common language and common expectations across all stakeholders. And again, when you go into production, this is very important because what used to be in the past was that all different brands were asking different things to the supply chain. So they were stretched here and there. They were not really able to understand what to do. But if all brands put their effort together, they just do a single request to the supply chain, then there is the reaction. And the reaction is an improvement from a sustainability perspective and a reduction of the impact on ecosystem and biodiversity. So basically, ZDHC was founded more or less 10 years ago. So actually it's 10 years ago because it is our anniversary this year. And we have been founded following the Greenpeace detox campaign. So if you look on the web, you will be able to find a lot of YouTube videos and a lot of documents made by Greenpeace over the years. And after the detox campaign that basically put the ownership and the responsibility of the environmental pollution on brands, some leading brands recognized the need for a collaborative approach. So they put their effort together. They were 10 years ago. Today we are more than 380 companies. And the vision is simple. If I read it, because our vision is a world where better chemistry protects life, land, air, and water, but in practice, this requires a lot of work from the supply chain. But this vision really focuses on the importance of chemistry. This is not an isolated topic. This is not something that you have to do, or just because you need to dye something, then you have to manage chemicals, but if you manage them consciously, then you can really improve the benefit on life, land, air, water. So also workers will have a benefit from them, also people living in the surrounding area of the production sites. So our mission is equally ambitious because we would like to lead the global value chain towards the higher standards of sustainable chemical management, resource efficiency, and circularity. Because do not forget that chemistry is a pillar of circularity, because we would like to keep garments more and more, 20, 30, 40 years, but what happens if actually they contain harmful chemicals? They just stay around for more time and they contain harmful chemicals. So a conscious, sustainable chemical management is also helpful for that. So as I mentioned before, we are now more than 318 organizations that are signatories of ZDHC. So basically they sign the commitment to implement the sustainable chemical management of the ZDHC Roadmap to Zero. And our signatories are very diverse because they are brands. They are suppliers that for us are the manufacturers of garment, shoes, and leather product. We have chemical formulators. We have several solution providers, so laboratories, consultant, organizations that are doing certification according to our principles. And we have also included recently the machinery manufacturer because they also represent a key element for doing improvement. And this diversity is extremely important because all the different stakeholders participate into shaping the roadmap and they try to do it in a meaningful way. And the scale of participation demonstrates that sustainable chemical management is becoming an industry priority rather than just an isolated activity. As you can see in this slide, we have some of our signatory brands. Yeah, it's not big enough to contain all of them, but I'm sure you can identify some of your favorite brands or maybe some of your potential client or whatever. To be signatory is not the only prerequisite to make the implementation actually of the supply chain of the ZDHC Roadmap to Zero. So basically, signatories are contributing economically, but also with their technical expertise to the program. But then the implementation is even wider. So if you see from this slide, we have more than 14,000 suppliers. So company making garments, basically, that are doing and implementing the sustainable chemical management from ZDHC. More than 3,400 chemical formulators are in our database, and they basically produce and put on the market formulations which are less risky for the environment and are not containing certain hazardous substances. These formulations are more than 155,000, so it's a huge population that we have in our database, which is named the ZDHC Gateway. And we have hundreds of laboratories that are approved to test these formulations, but as well to test the wastewater. Because, we have a whole integral setup for the implementation of the ZDHC Roadmap to Zero. Basically, we have the guidelines. So if you go on our website, you see documents which are including limits, testing approach, parameters, values. We have the ZDHC Academy. So you can find a website of the Academy. Again, you can freely subscribe to it. And basically, this is because we need to build the skills within the value chain. So there is no implementation if people working in the industry is not clear on what to do. And then we have the implementation hub that is where our approved laboratories sits for doing testing and analysis. Let's say that our implementation model is quite simple and quite logical. We start with input. So for us, input means chemicals utilized in the production processes. With our MRSL, which is the Manufacturing Restricted Substances List, we put limitation on content of hazardous substances in formulations, and we as well ban the use of certain hazardous substances from production processes. Let's say that usually in the past, people were considering content of chemicals in the final product, based, for example, on REACH requirement. With ZDHC, we look at the production. So basically, if you phase chemical immediately at the beginning of the production process, you will not have them in all the environmental matrices, but as well in your final product. Of course, then we have the manufacturing process. So basically, how sustainable chemicals manufactured in compliance with the MRSL are utilized in the production process. And at the end, we measure the output. So to measure the output is a way to control if everything was good in the process and in the input. And when we refer to output, for the moment, we have our main guideline in the wastewater testing approach, which is going beyond legal requirements. So legal requirements are often focusing on certain conventional parameters, but we are including hundreds of organic chemicals, which are the same included in the MRSL. We also consider the air emission, and we will soon have a guidance document applicable also to waste. And let's say that having worked 10 years on the ZDHC roadmap to zero has raised a critical question. So how do we demonstrate that this sustainable chemical management actually benefits nature and reduce impact? So how we say it's not just an exercise of implementation, but really there is a reduction of the impact of the production processes on nature. So this was quite a challenge because traditional methodologies were not designed to answer this question. To gift ourselves a present for our 10 years anniversary, we have appointed Quantis, which is a lead sustainability consultancy, to help us to understand which was actually the reduction of the impact coming from the implementation of the ZDHC roadmap to zero. So they have developed a pioneering impact assessment approach, which was based on a life cycle assessment principle that were adapted to specifically the sustainable chemical management. And we have selected certain indicators that are scientifically robust and specifically addressing the sustainable chemical management space. These are freshwater ecotoxicity, human toxicity, water use, eutrophization, and climate change. And this study for us has been very, very important because we have been able to demonstrate a little bit of reduction of the impact. Of course, before going into actual measurement of the reduction, there was the need to understand what are the nature pressures that has been identified by AIPBES, and these are land use change and sea use change, direct exploitation of resources, climate change, pollution, and invasive species and other threats. You can see from this slide that on 5 indicators, 3 are strictly related with the chemicals. So really, we have decided to focus on these indicators. And let's say that the methodology was based on real-world case study, so some facility volunteered themselves to do this exercise, and the evaluation has shown that the reduction of the impact is happening specifically in 3 cases. One is when there is the substitution of hazardous chemicals, so basically when production processes utilize MRSL compliant formulations. The other one is where wastewater guidelines issued by ZDHC were applied. So basically, there were improvement wastewater treatment and improvement quality of the water itself. And then we also have experienced a reduction of volatile organic compound emission. Sometimes primary data were incomplete, so they have been completed with scientifically recognized secondary set of data. And in this slide, it's big enough to see, something. The results, as you can see, are extremely encouraging. You see many green arrows pointed down. Across various case studies, we have observed substantial reduction in environmental impacts. In many cases, freshwater ecotoxicity decreased by more than 80%. Human toxicity showed significant reduction. Water eutrophication was substantially lowered. Climate-related impact also improved. Of course, we have still some red arrows, so anything is perfect here, but we are working toward improving our capacity to measure this reduction of the impact. So this is really a way for us to demonstrate that sustainable chemical management is needed, is not simply an implementation exercise, is not simply a reply to the detox campaign that was made 10 years ago, is something that should be improved for the future. Of course, if you want more information on the ZDHC, you can rely on our website. We have an extensive knowledge base that will also help you to navigate our requirements, and you can visit it. There is also a nice AI tool that can help you in that. And thank you. This is the website and the email for any question.
Thanks, Elisa. Now, floor is for Francesca Rulli from Impact. Come si mette? Io questo. Come si mette a schermo intero il PDF? Cliccavo quella giusta, ma non lo facevo.
Good morning, and thank you for this opportunity to share some thinking about sustainable fashion and also our path. We started as Impact in 2014 because we were so curious about fashion. Can fashion become more sustainable? This was the question at that time, and today we are in a very interesting moment because we are passing from a phase that we can call voluntary to a new important phase for this sector and for other sectors that start to become mandatory on sustainability. So also brand and supply chain that till today didn't start the roadmap. Today they have to face the challenge. I am a co-founder of Impact. Impact is, some words about us, is an ecosystem, is a group of experts. We start in 3 persons. Today we are 80 persons in Italy. And we are the green job that sustainability pushed to build also in our country. And we combine multidisciplinary skills together with a platform, so an interconnected technology, because as we see in some minutes, data management is the key factor that help the processes and so the production phases to reduce impact, social and environmental impact. As I mentioned before, the fashion system is facing a very big transition. We can say now that the value chain has collapsed. So business models are not reaching the targets during the last years. So there is a big new era arriving in the fashion and luxury sector. And this is pushed from the collaboration between brands, supply chain, and consumer. Consumers are pushing in a more conscious purchasing. Brands have started during the last 15 years, 10 years, to change their way to design and to produce fashion and luxury products, and supply chain is really engaged in changing industrial processes to reduce impact. And in this way, production phases and design phases have to be rethinked, have to start a new way through which designers and suppliers and manufacturers have to think how use water, how to use chemicals, how to use energy, how to protect people. And when we started, we didn't have methodologies with scientific approach to support suppliers and brands in implementing this strategy. So this sector started with big commitments, big manifesto, some capsule, but nobody was able to transform the production model in total, in all the production phases. The milestone of this new approach are absolutely the two within the slide. So the supply chain and ESG, risk and impact management, and the process and product traceability that arrives to DPP. I try to say something really simple. If we trace data that demonstrate us the risks and impact along the processes, so along the supply chain, we are really able to say, yes, this product is sustainable, is reducing impact. So data is the key factor. Traceability, data, and methodology are the key factor that help to transform the sector. Some years ago, Global Fashion Agenda helps us to define what we can say the materiality of this sector, so the key priorities for transformation. And these are the priorities that the sector is facing and working on to reduce this impact. As you can see, there are some priorities that are social priorities and some that are environmental priorities. Speaking about resource stewardship, so water, energy, air emission, we face here also the chemical management and environmental impact reduction. So what Elisa said before is linked to this resource stewardship. And as you can see, during the last 15 years, about 15, 20 years, lots of initiatives, coalitions, methodologies, standards, certification help the sector to face this transformation with a voluntary approach. But today, is arrived a mandatory approach. What are the main driver of this mandatory revolution? There are lots of new rules arriving to this sector, but I try to focus on three main drivers. One is supply chain responsibility. Brands become responsible also for their production models. So they become responsible not only about what they sell, but also about how they produce. Product traceability is the second one. So the DPP and the ESPR is the driver, the new regulation that push the sector to trace information about risks and impact, to help the consumer also to have a new education in their purchasing, and then end of life that push circularity. So all the regulation that enable the sector to use in a different way waste and to extend the life of each product. The role of the coalition is so important because otherwise there are no methodologies for this sector to implement the strategies. So as we have listened from Elisa, ZDHC, but also Textile Exchange, Fashion Pact, lots of initiatives and coalition combine efforts, define methodology, and support this transition along the supply chain. Here some example, but we already listened. ZDHC drive the chemical management with the roadmap to zero, so with combining a program that help brands and suppliers to implement the same MRSL, the list of substances they have to ban from their processes, with a clear methodology, so a clear system that help to measure this reduction. This is a clear example of how applying a standardized and harmonized methodology, each supplier, each tier in the supply chain can contribute to measure this impact reduction. And the same we have for decarbonization program as Fashion Pact program, AII program. One example I can say is in Fashion Pact program, we have also some dedicated activities and methodologies to avoid use of plastic along the processes and for the use of materials. All these examples help us to understand that data management, process flow, traceability, and scientific approach is the right way to help the sector to transform the business model, the production model, toward the digital product passport. And this is the new era. In a couple of years, we will have an ID on each item that we will buy as a consumer, and this digital product passport will tell us the story of how this product has been produced. So what the sector is facing, and today we are really well engaged with brands and suppliers to help them to do this job, is to collect tier by tier, tier 4, tier 3, tier 2, arriving to the final product, all the data that can help the consumer and the DPP to have the right story. These are some information. We are waiting from the European Commission through the delegated act that will tell us what are the key factors to insert in this DPP. But what is really interesting is that the DPP is not a list of information that the brand can insert in the product. The DPP is an architecture that connects brand with all the suppliers to collect information and provide the final data in the final product. So it pushes a really different collaboration between all the suppliers and the brand to work in the same direction of the reduction of impact, social and environmental impact. Thank you.
Thank you, Francesca, for this, this talk, because she opened the issue of the data, she opened the issue of the measurements and the collection of data and the fairness of data to support the transformation in this sector, and to open this discussion to the, let me say, to the science and to the next future of how to get data and how to use the data for supporting this transformation, for example, for the DPP. Thanks, and now we are welcoming Raffaella. I don't know if you prefer to come here for the slide change. To sit down here, if you preferisci stare lì.
Thank you very much. Good morning. Okay. Thank you very much. Thanks to organizer for inviting me to this interesting workshop. Good morning, everyone. And before starting, it is important to define what microplastic is. Microplastic is a material consisting of a solid polymer containing particles to which additive or other substances may have been added, and where more than 1% weight particle have two kinds of dimension. The size between 100 nanometers and 5 millimeter. Okay. Sorry. Now it's okay? It's okay? Okay. Allora, I start again. In this slide, I described the concept.
Try this way. Raffaella, if you want, please.
Ciao. It's okay. Okay. Sì. I start again, okay? Okay. Good morning. By title, my presentation is Factors Influence Microplastic Fiber Release from Textiles During Washing, Implication for Eco-Design. Before beginning, it's important to describe the concept of microplastics. Microplastic is a material consisting of solid polymer containing particles to which additives or other substances may have been added, and where 1% of weight particle have two kinds of size. The first one is between 100 nanometer and 5 milliliters, and the second one for fibers is specific for fibers, is a length between 300 nanometer and 5 millimeter, and the length diameter ratio more than 3. Polymer that occur in nature, that have not been chemical modified, are excluded, as are polymer that are biodegradable. SAMI project, our project, co-funded of Programma Regionale Piemonte, responds to the need to reduce pollution caused by fibrous microplastic released by synthetic fabrics during home washes. The main objective of this project are the definition of the eco-design criteria through the choice of operating conditions during the production phases, the development of a sustainable and durable anti-release surface treatment without compromise their mechanical, thermal, and comfort quality, and the hand drafting of guidelines for a production garment designed to minimize the release of microplastic fibers based on the relevant outcome of the point 1 and 2. These goals are being achieved thanks to involvement of industrial partners covering all production stages, from spinnings to garment manufacturing. The material that used is the PET. Why PET? Because polyester in textiles, the fibers. Polyester continues to be the most widely produced fiber in the world, accounting for 59% of the global fiber production in 2024, whose more than 12 is recycled. A solution to reduce microplastic release must necessarily involve a structural optimization of virgin and recycled polyester, kind of, for example, GRC. The quantification and identification of microplastic release from the sample were carried out by ISO 44841-2 series, is a protocol standard published in 2023. There are two kinds of determining the material of microplastic. The first one is ISO 44881 for the determination of material loss from fabric during washing. And the second is 44844 for identification and classification of the microplastics. In this slide is reported the methodological path used for experiment. They are composed of 5 steps. Step 1, scarring of the samples. The step 2, application of 44841, the elaboration of the data, then application of ISO 4484, and then elaboration of the data. Before analysis, all the samples were subjected to a scouring treatment at 60 degrees centigrade for 20 minutes, both to eliminate residual contaminants deriving from the manufacturing process and to standardize the sample before testing. For commercial PET textile sample representative of the PET typical market products, such as T-shirt, sweatshirt, shirt, trousers, were replicated by using controlled traceable textile parameters. We work with 2 different kinds of knitted fabrics, jersey and jersey vanise, and orthogonal structure, plain wave and satin. In this slide, the yarn castrace parameters is reported. For example, textile geometry, kind of material, the fiber lengths. In this case, we prepare the material with staple fibers, no continuous filament, spinning yarn, for example, ring, and yarn count, the characteristic of the yarn. For example, yarn count, twist, and so on. All the samples were, moreover, all the samples were characterized through the mechanical and comfort test to investigate the relationship between fabric properties and microplastics during washing cycle. Another aspect very important is the assessment of finished treatment on the microplastic release and mechanical properties. And this step is under investigation. Each category, because for polyester fiber it's possible to dye in 3 ways: dop dye, yard dyed, and pizza dyed. And after that, all the samples are finished with chemical, with the standard heat setting, standard finishing, chemical, mechanical, and chemical-mechanical. In this slide, we can see the box plot of release data for the sampling after the first and the fourth washing cycle. The samples are dop dyed, grade, and pizza dyed. And 4 replicates were tested for each samples, and the average value was used to compare grade and other samples, the dyed samples. The release value are expressed is a milligram for kilos of fabrics. As you can see, piece or dyeing show higher average release value than the corresponding gray and dop dyes. Another aspect very important, as you can, that the samples show higher microplastic release during the first washing and then for further washings. But in this case, the textile geometry of the dyed fabrics does not influence microplastic release during washing, as you can see in the histogram. In this case, we compare jersey, plain wave structure, and vanise, but there isn't a statistical significant difference. As you can see in this case, the result of the graph shows that piece dyed in the center of the graph release more material loss than gray and dop dye samples. And in the second histogram, in the piece dyed, in particular the first washing, after the first wash, there is a lot of material loss than the third. And so we study this behavior. Why? Analyze the material loss and discover that there is fibers mixed of particle. And this particle, after a chemical analysis and some analysis, is oligomer of PET. This is the SEM morphologic analysis detected particle lower than 1 micron, and so reported to a PET oligomer in dyed piece fabrics and dyed piece fabrics scored at 60 degrees. This indicates that scouring at 60 degrees doesn't completely remove oligomer when the weight concentration is very high. The sample, the particle, was analyzed with chemical analysis, in particular with spectroscopy analysis, micro-FTIR, and compare the spectra, and in fact it is a PET oligomer. But why there is this problem? Because PET dyeing occurs at high temperature. Oligomer migrate to the fibers of fiber surface to the wash, to the bath. In piece dyeing, the bath is called drain, and so during cooling, the oligomer can redeposit onto the fabric surface. And probably during the washing cycle of the fabrics, thanks to the mechanical friction, this promote to release of oligomers, and so material loss when there is a filtration of washing effluent on the filters. We collect particle and fiber, but this particle is oligomer. Another aspect very important for the eco-design, future eco-design of, for example, the garment, is the fiber length. In generally, we can see that the samples release fragment fiber lower than 100 microns. The box plot shows that the dyeing process has a clear effect on the fiber length. Dop dyeing and gray fabric generally exhibit higher median fiber length than piece-dyed samples, which tend to release shorter fibers until 40 micrometers. These observations are consistent with the statistical analysis which identified the dyeing process as the most significant factors affecting fiber length. In contrast, we have the structure. There are no support, there are no difference. It's not determined, this behavior is not determined of the structure of the textile geometry of the fabrics. The same conclusion can be drawn from the frequency histogram. Another aspect very important is to determine the mechanical properties and relation them with microplastic release. We tested for all the samples. In this case, we show a result for jersey, so knitted fabrics, jersey and jersey vanité, and the tests were mass per unit area, perforation resistance, and peeling resistance. It's want to underline that piece dye samples show higher mass per unit area than dop dyed and gray samples. Piece dyed samples show a lower peeling resistance than dop dyed and gray samples, and this aspect is possible to correlate with shorter fibers, because it's possible that forms a peels, and this peel is removed during the washing cycles. And finally, jersey vanissé, and so in particular structure, jersey vanissé piece dye sample show the highest perforation resistance. All these properties are investigated with the protocol standard Uni-ISO-N. But in conclusion, the result suggests that piece dyeing play a key role in the both fiber release and mechanical behavior. And so final is possible to conclude with the key findings. Piece dyeing, so this particular kind of dyeing, increased material loss compared with the dop dye and grade fabrics. Material release is highest during the first washing cycle. Eco-design strategy should consider dyeing process in addition to fabric structure. The work of this project is in progress, and the next step will be complete collection of data on orthogonal textile, because I study 2 knitted fabrics and only 1 orthogonal textile, plain wave. Assessment of finished treatment influencing microplastic fiber release, and the hand assessment on the recycled PT influencing microfibers release during washing, in order to compare PT recycling and PT fossil. Thank you very much for your attention.
Thank you, Raffaella, for this very interesting presentation. Now it's my pleasure to introduce Irantzu Carmendia Aguirre from the Joint Research Center of the European Commission, who will introduce us to the SSBT framework.
Okay, good morning, everyone. So first, I would like to thank the organizers for giving us the opportunity of presenting here the SSBT framework. For those that are not familiar with it, it's the Safe and Sustainable by Design framework developed by the Joint Research Center for the European Commission. Briefly, in order to put it into context and to know why we are talking about the SSBT, I will introduce the policy context in which it was developed and in which it has been further improved. Then I will focus on the last version of the framework because there are 2 publications. And then last, if I have some time, I will give some indications about textiles in the context of the SSBT, although I think that a lot have been already said. Okay. So, you might be familiar with the European Green Deal ambition that was published already some time ago, end of 2019, where with the ambition towards climate neutrality, zero pollution, and circular economy. And you might as well be aware or familiar with some of the strategies that were already published in order to achieve these ambitions. And I have listed some of them here, but of course we have as well heard a lot about the eco-design sustainable product regulation. But here we have as well the chemical strategy for sustainability that is key in the context of the SSBT, because the chemical strategy for sustainability talks about tackling the problems that we have in the environment and with the human health exposed to these chemicals, and the ambition on how we can solve this problem. And one of the actions that the CSS foresees that it's needed, it's to develop a framework to support the design and development of new safe and sustainable chemicals and materials life cycles in the European market. But of course, we are also familiar with the new European ambition, that is the competitiveness compass that was published in January 2025, and that also has some similar ambitions as the Green Deal, but also more ambitions towards the competitiveness compass of Europe. And here as well, as you see, there are some listed initiatives and strategies that have been already published or that will be published soon. One of the aspects that is common to both ambitions in Europe, if you look at it in detail, we mentioned in the Green Deal, the chemical strategy for sustainability and the innovation. But in the competitiveness compass as well, we have as a key pillar the innovation, the need to innovate in order to achieve these ambitions. And here is where the SSBT plays a key role, because actually it links the 2 ambitions with this key pillar that is the innovation. But of course, All this didn't happen so fast as we have the first publication, and then we have the competitiveness compass, and we make this link. You can see in this slide that, as I mentioned before, we started with the chemical strategy for sustainability, this mandate of the GRC to develop this framework based on a concept that was defined there, and that also comes from the OECD. And there we have tested in different forums the framework. We have received feedback with the stakeholders. It has been a collaborative effort with a lot of exchanges, and out of this is where last year, in December 2025, we published the revised framework. So we started, as I said, from a demand that was based on the Green Deal ambition, looking at going beyond existing regulations with regards to chemicals, but supporting the innovation. That's the reason why the first framework was based in these premises. We have the innovation, we redesign something, we have a concept, we assess it, and then we decide whether the solution is safe and sustainable by design. However, with the experience that I mentioned, we started collecting a lot of feedback asking, okay, yeah, this is perfect. We have the requirements that are almost to put something on the market, but how do we operationalize this in innovation? And in order to answer this question, we also needed to define why we are applying the framework and what is the framework about when we are talking about it. So basically what we did and how we integrated better in innovation. Instead of saying innovation first and then we focus on the assessment, how we really integrate the assessment in this innovation and mirror what happens in innovation. Innovation, it's not one straight line. We have a concept, we developed, and we put it on the market, we assess it, and we put it on the market. No, it's a cycle where we commit errors and we need to reiterate the cycle. So this is a bit what the framework tries to mirror in this case. However, always keeping the same ambitions that we had from the beginning of the framework. So the answer that we need to reply to before we start developing the how is what. I'm happy that some people already talk about paradigm shift because sometimes I am the only one claiming that, but the SSBD actually represents a paradigm shift on how we innovate. What it does, it's a proactive, preventive, and voluntary approach because we are talking about innovation towards the design of chemicals, materials, processes and products. We also heard that it's not only important the product, but also the processes and how we start from. Integrates safety and sustainability considerations to ensure that the potential impacts of the innovative solution to the human health and environment are minimized while still, of course, meeting other needs of the innovation. It's not only about replacing one chemical by another or changing one formulation or one process. It needs to be looked at from the holistic life cycle perspective. One innovation upstream might affect downstream. For that reason as well, we heard a lot, it's a collaborative effort. It's not enough that the innovator tries to apply it. It has to be an entire value chain, supply chain effort. It's about rethinking, as I said, not only doing once the innovation to ensure that the innovative solution proposes a consistent ambition of safety and sustainability, not only in the short term, but also in the long term. And as I said, it aligns with the European policy ambitions. So this is basically now talking about the revised framework. What we tried to do is to have very clear that these are the pillars, the principles of the SSBD that we all agree with and that we all globally as well can implement it. Because then the operationalization, of course, in the case of the SSBD European framework goes to the European regulatory needs. It's basically what I said, safety and sustainability needs to be considered throughout the entire innovation, and for that reason it's iterative, but it also introduces the aspect of the data. It's as well tiered in the sense that we start with little data and then we need to elaborate on that to make a robust assessment of safety and sustainability. It's about the life cycle. For that reason, it's the need to have a multidisciplinary and multi-value chain engagement actors. And we also, I think that we talk about its need to be transparent in the sense of how we have applied it, and also traceable with regards to the information that we generate with regards to these chemicals, materials, processes, products, and the safety and sustainability behind them. So one important thing, as I said, because of this cycle, I am starting to repeat a bit myself, but it's that it follows the innovation throughout the different life cycle stages of the innovation. It's not only about redesigning, but also how we prototype, scale up, and in the end, we make sure that we are ready to place it on the market and to, of course, comply with the marketing requirements. But it is also have to be acknowledged that innovation can happen in many, many different aspects. Here, only talking about textiles, we saw that there are many things that we can work on, from the dyes, from resource-related aspects, consumer demands with regards to the products, et cetera, et cetera. And this can be extended to thousands of different supply chains, applications, et cetera. So what we also introduce in the revised framework, it's the concept of how we, from this initiating innovation, we can apply the framework in a consistent and harmonized way. And for that, we introduce the scoping analysis that basically contextualize the innovation, whatever innovation we do, with these principles that I mentioned. So what is the system that we have? What are the ambitions with regards to safety, sustainability? What are the actors involved, et cetera, et cetera. So there we can know where we are, where we want to go, and what is how we are going to do it. A bit, again, what I just mentioned, I started talking about the SSBD like a mountain that we want to climb, and the ambition is the summit of the mountain. We have different scenarios, different cases, and each one of them is different, right? We can start from scratch, wanting to solve a big problem, top-down approach. We can as well start from a problem that we very well know, but we want to improve, bottom-up approach, with things that we know, with things that we don't know, with more stakeholders engaged or less. So we have different scenarios where we can see our innovation trying to reach this summit. And basically, we have as well different stages where we start from. And basically, what the scoping analysis does is an analysis of where we are and where we want to go. So we can plan what we are going to do in order to achieve these short-term or long-term ambitions. And this is the camp where we put our face base, is what the scenario tells us about. So once we have that clear, then is when we can start talking about how we do the assessment from a holistic perspective, trying to reach all the aspects of the safe and sustainable and the life cycle, but we also can start from a very targeted perspective and then broaden the scope. So, but once we have the scenario, we can decide as well on that one. And when we have the planning, we have the scenario, we have run the assessment, then it's when we can evaluate according to this, what is my status and what are the next steps that I need to follow with regards to the innovation, the assessment needed for this innovation targeted to functionality, but also to safety and sustainability. And as we said before, it is important that we keep transparency with regards to how we have done and traceability, because it is not important to tell us what went well. It is also important to understand what didn't go well and what we did in order to address these problems. So as I said, this is the how. In conclusion, what are the benefits of the SSBD? So it encourages companies to collaborate. We have seen that this is missing very often due to confidentiality, due to competitiveness. The benefit of SSBD is that we are talking about innovation, so there is a better chance to foster these collaborations and to keep them long-term. It manages and supports minimization of innovation risks. By doing it stepwise, we ensure that the risk of the innovation will be lower or there won't be any risk at all. By considering the socioeconomic impacts helps companies to balance safety and sustainability with cost effectiveness, so making the solutions economically viable. And because it is framed in the context of the European regulatory framework, it also ensures, as I said before, that solutions are not only safe and sustainable right now, but they are future-proof as well. And of course, this we also start hearing more and more that it's attractive to be communicated to our customers and investors. As I said, I have a couple of slides about textiles, but it will be very short because I think it has been mentioned already. What is the innovation in the textile industry? It has been mentioned a lot, things related to sustainability, water, and energy consumption, but also waste generation, look into the processes. We also look at the chemicals in the sense that they are more sustainable, bio-based, biodegradable. One thing that we also mention is related to that it's a sector that it's very customer-driven, and we mentioned the color coding problems that we have, but something that it has not been mentioned and that it's very linked to the SSBD that worth mentioning, it's as well all the functionalities that we are trying to develop for the textiles. And here I put some examples, like, I don't know, some of them are already quite familiar. No, we have the antibacterial, the flame retardancy, but we are looking as well for other technologies to be incorporated in textiles. And this cannot be done with advanced materials, with nanomaterials, that are the technologies that we are seeing as the solution of all our problems. And this as well, it's very, very much considered in the context of the safe and sustainable by design. That's the reason why we talk about chemicals and materials, processes and products. So to bear in mind as well that it's applicable for these cases. And then in the first presentation, ETP talked about all the activities that they do, but maybe I wanted to mention that there has been some activities ongoing in the context of the SSBD related to textiles. One of them is the case studies that the JRC ran in 2023, where we already tried to address one problem in the textile sector, that it's the use of surfactants in the scoring of textiles. So there is already an example there that you can look at. I wanted as well to mention the ETP project within the IRIS SSBD community, where they have 7 value chains that they try to look at the opportunities and challenges applying the framework in the sector, so quite holistic. I think that the roadmap is not published yet, but once it is, worth mentioning, because they also tackle all the different places in the value chain where innovation is needed. And of course, there are many, many other projects, Horizon projects that are taking place now, that one of their case studies is always textiles, like the one in Integrano that Massimo is going to present now. So I would like to finish my presentation, as always, mentioning that this is not a single person effort. In the JRC, we are 2 units working on it. And of course, I would like to thank to all my colleagues there, starting with Elisabetta Abate, Giulio Bracalante, Lucia Mancini, Grazia Capucci, Davide Tosques, Kirsten Rasmussen, Birgit Sukulkuten, Hubert Rauscher, Michael Bennett, and Serenella Sala. Thank you very much.
Thank you, Iranzu, for this introduction on SSBD. I would like to leave the floor to Massimo Perucca from Project Hub, who will present some results and applications by the Integrano project, which is one of my favorite projects because it's coordinated by University of Milano Bicocca. But I would like just to say that if you look at the call from the Commission now, you will find SSBD written in almost all the calls, asking for new products, new processes, new advanced material, and so on and so forth. So we are speaking about something which is already real, but with Massimo, we will taste how the different dimensions of the innovation, not only the functionality, but the environmental, social, economic dimensions are treated, and the data are retrieved and managed through innovative digital systems. So that's in my mind, among the most important things in this field. Thank you, Massimo.
Thank you all for being here, and thank you Faride for coordinating Integrano project, and also for inviting this rich panel of speakers. I almost filled my blog notes today, so to learn and to capture some messages. Project Hub I'm representing Project Hub, is a company that is dealing with innovation and sustainability since more than 20 years. When sustainability was not so fashionable, attractive, or known as today. Today I would like to focus on the point of methodological approach to operationalize SSBD, but also to support and drive innovation in the right direction in order to somehow support sustainable and safe, or more sustainable and safer solutions. This, of course, is implied in the Integrano project. I'm not, of course, presenting Integrano project. You can scan this QR code and get all the information and details of the project. I just want to remind you that it's formed by 13 outstanding partners, including GRC and, of course, University of Milano Bicocca as a coordinator of the project. It involves 8 countries, and it lasts for 4 years, with the funding amounting about 4 million euros. There are some methodological key points. I would like to, of course, highlight the point that we are focusing on different industrial sectors, and also dealing with case-specific studies. Today, we will learn that there are different points that are somehow implied towards the goal of sustainability, which is somehow dealing with parameters, variables that are implied in different processes. And we learn that in the dyeing process, there are so many variables in terms of finishing, in terms of selection of the proper dyes, temperature, amount of water, mass, water ratio, etc., etc. So all these variables have to be somehow selected in order to get to some performance factor, which also which may include, of course, key drivers like cost, but also drivers like environmental sustainability and safety. So Integrano is dealing with textile. One of the case studies is dealing with textiles, and we are addressing antibacterial finishing for textiles. I will not present scientific detailed data, but just I want to remark the methodological approach, which is implied also in this case study as all the other case studies. And case-specific data are related to the case we are considering, so the antibacterial finishing of textiles, including tox, ecotox data, functionality, and all the parameters that are implied in the development of the innovation. As I was mentioning, to get to the results, we need to be case-specific and quantitative. So we have to measure what are the effects that are implied and depending on the design options. So the amount of water, the kind of dye, and the temperatures, and all the processing temperatures that are somehow implied in a process. In this case, we have key decision variables that are affecting the performance indicators of our antibacterial textile that will tell us about functionality, social sustainability, environmental impacts, and cost. This is possible through the data management system and also through the development of dedicated tools based on artificial intelligence, which are dealing and elaborating experimental data, so case-specific and real data taken from real world. Finally, we were learning from the previous presentations that human factor is important. So also in decision-making, we have to take into account to inject this relevant factor in the decision-making process. So our system, our digital support system based on artificial intelligence includes the stakeholders, actors, or human factor in the decision-making, supporting the decision-makers in the last human-centric decision process to take the right decisions, to be sustainable, competitive, making a business case real and applicable in industry. We are not reinventing the wheel in Integrano. We are applying industrial processes in an innovation process that are based on Six Sigma methodology, and these are somehow aligned with the SSBD framework, which is operationalized by taking these main steps. So the definition of the problem, which is the scoping of the problem, which is defining the context, the variables, all details that are implying an innovation challenge. The measurement, so we have to generate data from experimental and modeling activities. We have to analyze the obtained data, and then we go to the design phase with humans, actors, experts that are able to decide on which variables, values to be taken. And then to the validation for assessing that the prediction of the artificial intelligence decision support system will somehow comply with real data that we can obtain in the field. This is the workflow of the project, and CS1 is a case study one implied in textile, but as you can see, the methodology is applied to all case studies, and this is somehow reflecting what is the main workflow. And these are the work packages within the project which will that deal with the measurement, data generation, analysis, and validation, design and validation. I don't want to enter into details, but I would like to pinpoint the definition, define the first step, which is the scoping phase, which is really, really relevant and driving all the development in the innovation. One more important point is that when we are designing a competitive, sustainable, and safer solution, we have to focus on different life cycle stage of the product. From raw materials, we will learn today about value chain, supply chain, DPP, all these key concepts. Of course, we have to take them into account in the life cycle of a material, of a product, and of its end of life. And Integrano is taking care of these steps through a stage gate approach, in which at each step of the life cycle stage we analyze the performance profile in all dimensions, environmental, social, economic, and functional. This is a snapshot of the scoping phase. I don't want to enter into details, but just to highlight you that we are somehow defining what are the key variables, the key decision factors which will affect the measurable, quantitative key performance indicators. And performance indicators could be, as we learned in the previous presentation, CO2 emissions, water use, eutrophication potential. There are 16 parameters just identifying the environmental potential impacts of any decision we may take. And then also more than 16, we are adding up to 64 if you include also the social dimension, including specific stakeholder groups. Of course, economic dimension, here represented with the gamma, and social dimension, and 5, functionality. So we cannot, of course, bypass the functionality point, because if we are designing a product that is very sustainable and low social impact, but it doesn't work, there is no business case. So we have to, of course, make a real case studies. This is just an example that is relating to Integrano and previous project, because Integrano is somehow coming from a previous great experience, which is Asina project. Some representatives here. We worked together for 4 years with CNR and also Unimib. So these are the key decision factors that were addressed in the synthesis of antibacterial agent to be then sprayed coats on a textile. And these were somehow the ranges of the variables that have been considered, and this is the design of experiments. So we define a minimum and sufficient amount of samples to be generated, from which we'll obtain an harmonized data set. This harmonized data set is key to enable the artificial intelligence decision support system to operate and to provide some predictions on safe and sustainable by design solutions. This is all the workflow from data generation that I was mentioning before. Ecotox, toxicity experts know what they have to do in terms of which samples to be analyzed. Also, the functionality assessors will check experimentally the antibacterial activity against specific bacterial strains, and also effects on mechanical property of textiles, uniformity, and all the key performance indicators that are addressing functionality. This is just a snapshot to evocate what is somehow the information that we can obtain by few points, data points that are obtained from experimental data sets. So for antibacterial activity, this is the solution. So these curves in surface plots provides you the idea where you have maximum KPI and somehow minimum impacts and minimum human toxicity potential. As you can see, they are not aligned. So we have to make a decision on which parameters, which are X and Y axis, to be selected in order to negotiate and find a realistic and applicable solution complying with the design criteria. That's why we need something which is supporting elaboration and decision. So we are at the step of analysis here that will enable decision makers to somehow discuss on which is the best solution to adopt in the end. And this is a picture that provides an outcome, an output of the decision support system. Here we depict in the 3-axis global warming potential, human toxicity potential, and on the other axis phi and gamma, so functionality and cost that have to be taken into account. So all these points are the key points of discussion for the decision makers. We don't have to imagine what could be deciding which point in this cube, which is the performance space. Not all performance can be achieved, okay? So we have to discuss on specific and real outcomes. And in the end, in the adoption, negotiation and adoption process, all the stakeholders will agree on one solutions that have to be generated as SSBD solution. This performance space you see on the right box corresponds to the 2D decision space. So all these points are somehow potential solutions that may lead to the specified performance levels. And this is, of course, what is obtained by the second stage of the life cycle. So from synthesis, we get to incorporation, and we get to the final results in terms of speed and amount of doping, of flow rate in terms of spray coating. I didn't want to enter into details of the process, but to give you the idea on how to proceed in a rationalized and efficient way. Just to give you an idea, this approach is applied also beyond Integrano project, in another European project called Texmater, that is, of course, dealing with the textile circularity based on bio-based sources from marine and terrestrial biosources to produce fibers and dyes for textile industry. And we developed a digital platform to support this sustainability and eco-design in textile, which is taking care of the whole value chain at global level, from raw materials, fiber sources, down to the final products and use phase and end of life. This was obtained also with the collaboration of JSC. We were involved in a project which yielded the ESPR preparatory study, which is has been published in December last year. Okay, sorry, I'm done. This, of course, addresses the eco-design approach in textile, also involving DPP. We developed also digital product passport, which is already in operation with some companies of our customer network. So I would like to conclude this approach and methodology. I wanted to be as sharp as possible since we are late. So data-driven and quantitative approach is a key point in our methodology. Case-specific, we have to be focused on a specific case study to achieve great goals. So from GSD, Global Sustainable Goals from United Nations, we have to materialize and get into details. And then we are applying a multi-stage gates and multi-level approach of SSPD, which enables to tackle complex problems, because we have many, many variables to comply with, and we have to consider different life cycle stages involving different tiers and actors. What is interesting and some beneficial is that we are just relying on a minimum and sufficient number of data points, which of course can be increased to refine the analysis, but still providing enough information to make early stage decisions. We need to work with harmonized data set, which might be also a limitation, but it's the power of the approach at the same time. And we cover all functional, environmental, social, economic, and safety dimensions. So we have a holistic approach considering all these KPIs at the same time. This will allow to take the right decisions, avoiding to discard early discarding some potential options. And the benefits for industry is clear. So SSBD, this one was one of the keywords that in sustainability is risk assessment. Yes, of course. It's risk assessment. So by applying an efficient SSBD approach, we can minimize risk to avoid regrettable substitution in the future. We, of course, guarantee that we are compliant with regulations, and also we can prove that in a quantitative way support decisions that are, of course, addressing the better sustainable and safer solutions at the present time, so with the best available technology so far. Finally, and not least for companies, so this approach enables to reduce the lead time from concept to innovation of 60%, which is money. Time is money. We were also mentioned this morning. And total cost saving is expected to do 80%, so minus 80% cost for innovation, which is quite important. Last but not least, AI is part of the tool, but it's not taking decision for us. We learn, unfortunately, in these days that if you rely totally on AI, it makes big mistakes. So AI is a powerful tool, but it has to be managed and used with aware and conscious approach. So it's a human decision-making, human-centric approach. So people have to take responsibilities on evidence results. And I think that with this, I also invite you to be part of the SSBD community, which is promoted by Integrano. You can go to the website, the SSBD Hub, or scan this QR code and be part of this community. Thank you.
Thank you, Massimo. We are already over time. It's time for a coffee break. And so if we have to close the streaming now of this hybrid event, I thank all the speakers, I thank all the public, and if anyone has some question, please, our speakers are available during the coffee break. And be back in the room at 12 for the opening ceremony of the Plastics and Environment Conference. Thanks to all.